Thank you. Hello, everyone. And my name is Tosin Adewumi from Luleå University of Technology. And these are my co-authors. And we present our work, Data Bias According to Bipol. Men are naturally right, and it is the role of women to follow their lead. Now, the title might seem provocative, but this is what our metric discovered in one of the benchmark datasets on the SuperGLUE leaderboard. That's the CB dataset. So I'll start with the introduction before moving on to some of the other subtopics you see here, and then we'll finally conclude with the conclusion. Now, I should ask, are these familiar? Some of these news items you may have come across in news headlines recently. The second one is particularly about ChatGPT. When a few months after it came out, there were quite a lot of discoveries about some of the biases in ChatGPT. And this last piece at the bottom is a news piece from Bloomberg, where they discovered some bias problems with stable diffusion. So first, it's important we define what social bias is. It is the unfair prejudice in favor of or against a person or entity. And this actually, unfortunately, is present in the data that we use in training machine learning models. So our motivation was to investigate the research question, how much bias exists in text of data of multiple languages, if at all bias exists in them. And we decided to investigate 6 benchmark datasets on the English, GLUE, and SuperGLUE leaderboards, and 1 dataset each for the 4 languages on your screen. We trained 2 state-of-the-art models, that's the MT5 and mBERT, on the MAP dataset for the different languages. And then we compared different bias evaluation methods and decided to go for Bipol, a recently released metric for bias. We also further confirmed the assumption, which was unverified, that toxic comments contain bias. So our contributions are this. We make available new large labeled datasets on bias, each one containing almost 2 million samples each for 3 languages, Italian, Dutch, and German. And then we also provide lexica for all these languages. And then, like we mentioned earlier, we confirmed the unverified assumption that toxic comments usually contain bias. The methodology we used in this work was to machine translate the original English dataset called MAP into the 3 languages, Italian, Dutch, and German. The Swedish already existed. And then we randomly selected 200 samples from the English dataset for the verification of the assumption we talked about. And then we hired annotators to do the annotation. And then we trained and compared MT5 small to mBERT base. The 10 datasets that we evaluated after training on the MAP dataset are these datasets, which you see on your screen. We compared Bipol with a lexical baseline in experiments for estimation. Now, on your screen, you see the data statistics. For MAP, we see that the total number of samples in the data set, including the training, the validation set, and the test set, is about 1.946 million samples. Then when we look at the lexica for the tables on the right, we see that we standardized all the lexica for Italian, Dutch, German, and Swedish. The English contains more items in the lexica. English is a high resource language, so it's understandable why English has more items in it compared to the other languages. Now, we said that we decided to settle for Bipol for some of the reasons, the advantages that it has. It estimates bias along multiple axes and provides explanation in form of a list of dictionary. And there are two stages. As you see with the equation on the right, equation 1A and 1B. 1A is what the first step it carries out is actually 1B, where there is a classification of the data samples into biased and unbiased samples. Then the second stage is similar to what you would find with term frequency, inverse document frequency, where it now uses the lexica to evaluate the frequency of terms, of the sensitive terms in the lexica. So the results we obtained showed that MT5 results are better than mBERT for all languages. This is not surprising, given that MT5 actually has is more powerful than mBERT. And then the results show that all the datasets have biases, even though little, but this is still important. You would see in table C the results of mBERT compared to MT5 with 0.787 for the English performing best. This is also not surprising, given that English is a high resource language. Then on the right, table D, you will see the Bipol results compared to the baseline. The baseline sort of exaggerates the amount of bias because it only considers the term frequencies, but Bipol is a more realistic evaluation because it looks at the semantics or explicit bias before looking at the term frequencies. And we see that the squad dataset actually appears to show the least amount of bias. Going further, we observe that there's relative consistency with model predictions. Even when sentences are perturbed or they are changed slightly, the model is still able to predict fairly accurately whether there is bias or not. We see this with some of the data sets that we evaluated. And then we talked about the fact that Bipol can produce explanations as to why a data set is maybe male biased or female biased. For example, the figure 1 you see there is the GNAT10 data set. It's a German data set, and you see that it has male bias, overall male bias, where there are more male terms represented compared to female terms. And then finally, the assumption of bias in toxic comments, we confirmed it, where we see that out of the 200 samples that were taken, 146 were confirmed to be biased, and then 54 were said to be unbiased. We used the Jaccard Similarity Index and the Credibility Unanimous Score for inter-annotator agreement score. Now, despite our findings, there are limitations to this work. The translated English dataset, the MAP dataset, may not contain culture-specific examples. When you do machine translation from English to any target language, there are culture-specific nuances that are not captured. For example, there may be biases that exist in, say, the German language or the Dutch language that would not be represented in the dataset. So that's a limitation. And the second one, the models that were trained are still limited in scope because the original MAP dataset only focuses on 12 axes of bias. Therefore, when we see a result of 0, it does not necessarily guarantee that the dataset is bias-free. So in conclusion, we have shown that bias exists in NLP datasets regardless of the language. All the languages we tested had some degree of bias. And interestingly, it may be impossible to completely remove bias from data or models since they reflect the real world that we live in. But resources for estimating bias can provide us some insight into mitigating these biases. As future work, one may explore ways of minimizing false positives in classifiers that are trained on bias to make them more effective. And then we can also check how this work scales to other languages, maybe other low resource languages, and how large language models can be deployed for similar bias estimation. Thank you very much. That was our presentation.